Hello, in this lecture we will find out the length of line segment X using three different methods. In the drawing we have a triangle ABC. We know that angle DAC equals to 45 degrees, angle ABC equals to 90 degrees, side AB of triangle ABC equals to 6 units, side DC equals to 10 units, and we want to find out the length of line segment AD that is equal to X. So we'll start with the first method, and here we will extend line segment AD by a straight line. So we'll extend line segment AD by a straight line. And from point C we will draw perpendicular to the extended AD. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction, and we will define the touching point of the perpendicular from point C and the extended AD as E. So here we have a right triangle, triangle AEC. And in this right triangle, we know that the sum of the angles must be equal to 180 degrees. So in the right triangle, triangle AEC, we have one angle that is equal to 45 degrees. This angle is equal to 90 degrees. It is a right angle plus angle ACE. In total, the sum of those three angles must be equal to 180 degrees. We'll subtract 135 degrees from this equation, and we'll get that angle ACE equals to 180 degrees minus 135 degrees is 45 degrees. So this angle equals to 45 degrees. And we also know that in front of equal angles in the triangle there are equal sides. So in front this angle we have side CE, and in front of this angle we have side AE. So those two sides must be equal to each other according to the rule that I mentioned. That is to say, AE must be equal to EC. Those two equal angles are located between the sides AE and EC. So AE and EC must be also equal to each other. Here we will define line segment DE as Y. So AE equals to X plus Y. A equals to X plus Y. And from this equation, X plus Y equals to AE equals to EC. We will derive that EC is also equals to X plus Y. EC equals to X plus Y. So we can write here that EC equals to x plus y. Actually, those two angles, they are defined as vertex angles, and we know that vertex angles are equal to each other. So if this angle equals to alpha, this angle must be also equal to alpha, because those two angles are equal to each other. Okay? And in triangle, the right triangle, triangle ABD, this angle equals to alpha, so angle BAD must be equal to 90 degrees minus alpha in order to complete the sum of the angles in the right triangle, triangle ABD, to 180 degrees. This angle must be equal to 90 degrees minus alpha, and then we will get that 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. Likewise, for the same reason, in the right triangle, triangle EDC, this angle equals to alpha, so this angle must be equal to 90 degrees minus alpha in order to complete the sum of the angles in the right triangle EDC to 180 degrees. So we actually proved that the right triangle, triangle ABD, this right main triangle, is similar to the right main triangle, triangle EDC, according to angle similarity rule. Here, those two angles, they are equal to each other, and they are both equal to 90 degrees minus alpha. Here, in triangle ABD and triangle EDC, the right triangles, we know that angle BAD is equal to this angle, angle ECD, and both those two angles, they are equal to 90 degrees minus alpha. I'll repeat again. Angle BAD equals to angle ECD, and they are both equal to 90 degrees minus alpha. Both those two angles, they are equal to alpha. So angle BDA, this angle, is equal to angle EDC, this angle, and they are both equal to alpha. I'll repeat again. Angle BDA equals to angle EDC, and they are both equal to alpha. And those two angles, they are also equal to each other, they are both equal to 90 degrees. So angle ABD, this angle, is equal to this angle that is actually angle DEC, and they are both equal to 90 degrees. I'll repeat again. Angle ABD equals to angle DEC, and they are both equal to 90 degrees. So all the angles of the right main triangle ABD can relate to all the angles of the right triangle EDC. Therefore, we proved that the right triangle ABD, the right main triangle, triangle ABD, is similar, this is the sign of similar to the right triangle, EDC. EDC according to angle similarity rule. Then, from the fact that the two green triangles are similar to each other, we will conclude that the following relationship exists between their sides. We will conclude that AB over DC, AB over EC, AB over EC is equal to BD over DE, and it is equal to AD over DC. I'll repeat again, from the fact that the right green triangle ABD is similar to the right green triangle DEC, we conclude that AB over EC equals to BD over DE equals to AD over DC. Here, AB is equal to 6 units, EC is equal to x plus y, and it is equal to BD, we leave it as it is, BD over DE equals to y according to our definition, and it is equal to AD is equal to x over DC. DC equals to 10 units according to what is given us in the question. So in conclusion, I found out that according to equation number 1, 6 over x plus y equals to BD over y equals to x over 10. We will find out the value of BD by implementing the Pythagoras theorem on the right green triangle ABD. In the right green triangle ABD, according to the Pythagoras theorem, here PT is abbreviation for Pythagoras theorem, we get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AD squared equals to AB squared plus BD squared. I repeat again. In the right triangle ABD, according to the Pythagoras theorem, AD squared equals to AB squared plus BD squared. AD equals to x, so AD squared is x squared, and it is equal to AB squared. AB equals to 6, so AB squared is 6 squared, that is 36, plus BD squared. BD is the missing line segment, so we leave it as it is. Here we found out that x squared equals to 36 plus BD squared. Here we'll subtract 36 from this equation, and we'll get that BD squared, is equals to x squared minus 36. found out that bd squared equals to x squared minus 36. Here we take a root out of this equation and we will get that bd is equal to the square root of x squared minus 36. Okay, we found out that bd equals to the square root of x squared minus 36. Now we can substitute bd in this equation number 1, by square root of x squared minus 36. We will do it now and we will get that according to equation number 1, six over x plus y is equal to bd, and bd equals to the square root of x squared minus 36 over y, and it is equal to x over 10. Here we will create two equations from this long equation. First of all, those two expressions, they are equal to each other, so this will be equation number 1. According to equation number 1, six over x plus y is equal to x over 10. Here we will cross multiply this equation number 1, and we get that according to equation number 1, 6 times 10 is 60, and it is equal to x times x plus y. We will open the brackets on this side of equation number 1, and we get that according to equation number 1, $60 equals to x times x is x squared plus xy. Here we will subtract x squared from this equation number 1, and we get that according to equation number 1, xy equals to 60 minus x squared. So we found out that according to equation number 1, xy equals to 60 minus x squared. In the next step, we create equation number 2. Those two expressions, they are equal to each other, so this will be equation number 2. So here we get that square root of x squared minus 36 over y equals to x over 10. So here we will cross multiply this equation number 2, and we get that according to equation number 2, xy equals to 10 times square root of x squared minus 36. So we have two different expressions for xy. So in the next step we will create equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. So equation number 3 states that xy according to equation number 1, that is equal to 60 minus x squared, must be equal to x squared according to equation number 2, that is equal to 10 times square root of x squared minus 36. Here we will square both sides of equation 3, equation number 3, and we get that according to equation number 3, 60 minus x squared equals to 10 squared is 100, and here the square cancels the root, and we left only with x squared minus 36. Here we will open the brackets on both sides of equation number 3, and we will get that according to equation number 3, 60 minus x squared equals to 60 squared, that is 3600, plus x squared, that is x to the power of 4, minus 2 times 60 times x squared, and it is equal to 100 times x squared minus 100 times 36 is minus 3600. Here we will add 3600 to this equation, and we get that according to equation number 3, 3600 plus 3600 is 7200, plus x to the power of 4 minus 2 times 60 is minus 120 x squared, and it is equal to 100 x squared. Here we will subtract 100 x squared from this equation number 3, and we get that x to the power of 4 minus 120 minus 100 is minus 220. It is actually minus 220 x squared plus 7200 equals to 0. Here we will substitute x squared by we will substitute minus 200x squared by minus 180x squared minus 40x squared. And we will get that according to equation number 3, x to the power of 4 minus 180 x squared minus 40x squared plus 7200 equals to 0. Here we will divide this expression to 2 parts, and we will take a common factor from each part. Here we will take from this expression, we will take x squared as a common factor. So what is left from x to the power of 4 after we took from it x squared as a common factor? What is left? It is actually x squared. And what is left from minus 180 x squared after we took from it x squared as a common factor? What is left? It is actually minus 180. From this expression, we take minus 40 as a common factor. So what is left from minus 100 times x squared after we took from it minus 40 as a common factor? What is left is actually x squared. And what is left from 7200 after we took from it minus 40 is a common factor? What is left? It is actually minus 180, and it is equal to 0. Here we will take x squared minus 180 is a common factor from those two expressions. And we get that according to equation number 3, x squared minus 180. So what is left from x squared times x squared minus 180 after we took from it x squared minus 180 is a common factor? What is left is actually x squared. And what is left from minus 40 times x squared minus 180 after we took from it x squared minus 180 is a common factor? What is left? It's actually minus 40. And this is equal to 0. So here we will have two solutions that are possible for x. The first solution for x is that x squared minus 180 equals to 0. And the second solution for x is that x squared minus 40 equals to 0. So according to the first solution, x squared equals to 180. 180 is equal to 36 times 5. Here we take a root out of this equation, equation number 1, and we get that x equals to the square root of 36 times 5. So x is equal to the square root of 36, that is 6, times square root of 5. And 6 times square root of 5, it is equal to 13.41, that is greater than 10 units. This is the first solution for x. And the second solution is that x squared minus 40 equals to 0, that is to say x squared equals to 40. We will take a root out of this equation and we will get that x, actually 40 equals to 4 times 10. We take a root out of this equation and we get that x equals to the square root of 4 times 10. The square root of 4 is 2, so it is 2 times square root of 10. That is equal to 6.32, that is less than 10 units. Okay, we have two solutions for x. The first solution is x equals to 6 times square root of 5, that is 14.41, that is greater than 10. And the second solution is that x equals to 2 times square root of 10, that is 6.32, that is less than 10 units. In the next step, I will copy triangle ABD, triangle ADC in a new page, and we will analyze those two triangles in order to find out which solution is correct according to the drawing. Okay. So we have right triangle, triangle ABD. This is triangle ABD, that is a right triangle. We will define angle BAD as theta. This angle equals to alpha. And here we have triangle ADC. We know that this angle equals to 45 degrees. And we also know that DC equals to 10 units according to what is given us in the question, and AD equals to X. So in the right green triangle ADC, we have three interior angles that are theta, 90 degrees, and alpha. And this angle ADC, is defined as an exterior angle of triangle ABD. Okay? So I write it down. Angle ADC, this angle, is defined as an exterior angle of the right triangle ABD, the right green triangle ABD. Okay? We actually have a rule that is related to the size of an exterior angle of a triangle. According to rule number 1, the size of an exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. I will read rule number 1 again. According to rule number 1, the size of an exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So according to this rule number 1, the size of the exterior angle ADC is an exterior angle of triangle ABD, so the size of this angle will be equal to the sum of the two interior angles that are not adjacent to it. Angle alpha is adjacent to angle ADC, and the two other interior angles that are not adjacent to it are theta in 90 degrees, and the sum of those two interior angles that are not adjacent to it is 90 degrees plus theta. So we found out that the size of the interior angle ADC will be equal to 90 degrees plus theta. Okay? And we know that the sum of the angles in any triangle is 180 degrees, and especially in triangle ADC, the sum of its angles must be equal to 180 degrees. So which angles we have in triangle ADC? In triangle ADC, we have one angle that is equal to 45 degrees. We have also this angle that is equal to 90 degrees plus theta. And we have also this angle, that is angle ACD, it is the missing angle. In total, the sum of those three angles must be equal to 180 degrees. Here we'll subtract 135 degrees from this equation, and we'll get that 90 degrees plus theta equals to 180 degrees minus 135 degrees, it is 45 degrees. We will subtract theta from this equation, and we'll get that here we subtracted 135 degrees from this equation, so we got that angle ACD, after we subtracted 135 degrees from this equation, we got that angle ACD, the missing angle, plus angle theta equals to 45 degrees. Then we subtract the theta from this equation, and we got that the size of the missing angle, angle ACD, is equal to 45 degrees minus theta. Okay, so the missing angle, angle ACD, equals to 45 degrees minus theta. So here we can write down that this angle equals to, angle ACD equals to 45 degrees minus theta. And from the drawing, it is very easy to see that this angle that is equal to 45 degrees minus theta, it is the smallest angle in triangle ADC. So I write it down. Angle ACD, that is equal to 45 degrees minus theta, is the smallest angle in triangle ACD. Okay. And we have also rule number 2 that is related to the smallest angle in triangle. According to rule number 2, the smallest angle in a triangle is always opposite to the shortest side. So I'll read rule number 2 again. According to rule number 2, the smallest angle in a triangle is always opposite the shortest side. So here, angle ACD, this angle is the shortest angle in triangle ADC, and according to rule number 2, it is located in opposite the shortest side. That is to say, according to rule number 2, AD, that is equal to X, is the shortest side in triangle ADC. So AD, that is equal to X, is the shortest side in triangle ADC. Okay? According to rule number 2, of course, but here we have side DC that is equal to 10 units, Therefore, according to rule number 2, AD that is equal to x must be less than the length of side DC. AD that is equal to x must be less than the length of side DC that is equal to 10 units. Here, for this equation, we will conclude that x is smaller than 10 units. Okay, x is smaller than 10 units. And we actually had two answers for x, two solutions for x. The first solution to the equation is x equals to 6.5 units, that is actually 13.41 units, that is greater than 10. So this solution is incorrect solution because x must be less than 10, and here, according to this solution, x is greater than 10, so we'll cancel this solution and we're left only with the solution, the second solution, that x is equals to 2 times square root of 10, that is actually equals to 6.32 units. That is, of course, less than 10 units. So the solution to the problem, to the question, is that x equals to 2 times square root of 10 units, or in terms of numbers, it is 6.32 units, that is less than 10 units. Okay, that is the solution to the question. In the first step, I will present to you how to find out the value of line segment x according to the second method. In the second method, we will do another construction. From point D, we will draw a straight line on AC in such a way that the angle that will be created will be equal to 45 degrees. So here, we will draw a straight line on AC in such a way that angle AED will be equal to 45 degrees. We can do it by construction in such a way that we will do the straight line in such a way, in such an angle that angle AED will be equal to 45 degrees. So here, in triangle ADE, we have two angles that are equal to each other. They are both equal to 45 degrees. And we know that in front of equal angles in the triangle, there are equal sides. That is to say, according to the rule that I mentioned, AD must be equal to DE. AD equal to DE. But AD equals to x according to what is given in the question. So from this equation, x equals to AD equals to DE, we will derive that DE is also equals to x. DE is also equals to x. And we also know that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ADE, the sum of the angles must be equal to 180 degrees. So which angles we have in triangle ADE? We have one angle that is equal to 45 degrees. We have the second angle that is also equal to 45 degrees. And we have the missing angle, angle ADE, that is equal and that is the missing angle, of course, and the sum of those three angles in total must be equal to 180 degrees. 45 degrees plus 45 degrees is 90 degrees, so we'll subtract 90 degrees from this equation, so 90 degrees will get cancelled, and we get that angle ADE, the missing angle, equals to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that the missing angle ADE is equal to 90 degrees, that is to say triangle ADE is a right triangle. In the next step we will define angle BAD is theta. So in the right triangle ABD, angle BAD equals to theta, therefore this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in the triangle to 180 degrees. Here, if this angle equals to 90 degrees minus theta, then 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. Okay? Here we know that triangle ABC is a right triangle, and BC is one side of triangle ABC. So BC is the side of a triangle, it must be a straight line. I'll write it down. Here, BC is a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BC at point D, then the sum of the angles must be equal to 180 degrees. So at the upper side of the straight line BC at point D, the sum of the angles must be equal to 180 degrees, according to the rule that I mentioned. So which angles we have at the upper side of BC, the straight line BC at point D? We have this angle that is equal to 90 degrees minus theta. We have this angle that is equal to 90 degrees, and we have the missing angle EDC. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Here we have 90 degrees plus 90 degrees is 180 degrees. We have 180 degrees on both sides of the equation, so 180 degrees will get cancelled, and we're left only with minus theta plus angle EDC equals to 0. We will add equals to 0. Here we will add theta to this equation, and we will get that angle ADC, the missing angle EDC, the missing angle is equal to theta. So the missing angle EDC equals to theta. In the next step, we will make another construction. From point E, we will draw perpendicular on BC. So this angle equals to 90 degrees, and this angle will also equal to 90 degrees according to our construction, and we will define the touching point of the perpendicular from point E and BC as F. So here we have the right triangle EFD. In this right triangle, we know that this angle equals to theta, so this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in the right triangle EDF to 180 degrees. In the next step, we will prove that the right green triangle ABD is congruent to the right green triangle, triangle EDF. The two right triangles can go into each other. So I write it down. We will prove that the right triangle, triangle ABD, can go into the right triangle, triangle EDF. Triangle EFC. Triangle EFC. So why the two green triangles can go into each other? First of all, those two angles they are equal to each other, they are both equal to theta, so angle BAD in triangle ABD is equal to angle EDF in triangle DEF, and both angles they are equal to theta. I'll repeat again. Angle BAD equals to angle EDF, and they are both equal to theta. In addition, we know that those two angles they are equal to each other, they are both equal to 90 degrees minus theta. So angle ADB in triangle ABD is equal to angle, this angle DEF in triangle EDF, and they are both equal to 90 degrees minus theta. I'll repeat again. Angle ADB equals to angle DEF, and they are both equal to 90 degrees minus theta. And side AD in triangle ABD is equal to side DE in triangle EDF, and they are both equal to x. Okay? AD equals to DE equals to x, so we prove that those two right green triangles can go into each other according to angle side angle rule. We have those two angles, and the side between them in triangle ABD can go in correspondingly to those two angles, and the angle between them in triangle DEF. Therefore, those two triangles can go into each other according to angle side angle rule. So we can write down that triangle ABD is congruent, this is the sign of congruent to triangle EFC. The green right triangle, triangle EFC, according to angle side angle rule. And from the fact that those two right green triangles can go into each other, we will conclude that AB is equal, side AB is equal to side DF. Side AB equals to side DF according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say AB and DF, will be equal to each other. But AB equals to 6 units, it is given us in the question. So from this equation, A6 equals to AB equals to DF, we will derive that DF is also equals to 6 units. Okay, DF is also equals to 6 units. And what is the size of line segment FC? the size of line segment FC. It is very easy to see from the drawing that DC minus DF equals to FC. Again, DC minus DF equals to FC. So FC is equal to DC, that is 10 units, minus DF, that is 6 units. 10 minus 6 is 4. So we found out that FC equals to 4 units. FC equals to 4 units. Likewise, BD equals to EF. Because of the fact that those two right triangles can go into each other, BD equals to EF. BD equals to EF, according to the rule that corresponding sides that can go in triangles are equal to each other. And if we define BD as Y, here BD equals to Y according to our definition, then from this equation Y equals to BD equals to EF, we will derive that EF is also equals to Y. EF is equals to Y. Here we can write down that EF equals to Y. In the next step, we will prove that the right big triangle, triangle ABC, is similar to the right small triangle, triangle EFC, according to angle similarity rule. Why those two triangles are similar to each other? So we will focus on the right big triangle, triangle ABC, and on the right small triangle, triangle EFC. This right small triangle, and we will prove that those two triangles are similar to each other. Why they are similar to each other? First of all, those two angles, they are equal to each other, they are both equal to 90 degrees. So angle ABC, in triangle ABC, is equal to angle EFC, in triangle EFC, and they are both equal to 90 degrees. I'll repeat again. Angle ABC equals to angle EFC equals to 90 degrees. In addition, this angle is a common angle, it belongs to both triangles. So this angle equals to itself. So angle ABC is equal to angle ECF. It is actually angle ACB. Angle ACB is equal to angle ECF. Why? Because it is a common angle that belongs to both triangles. Okay? I repeat again. Angle ABC equals to angle ECF. It's a common angle. Those two angles, they are also equal to each other according to third angle theorem. So I will write it down. Angle F is angle BAC in triangle ABC is equal to angle FEC in triangle EFC. And they are equal to each other according to third angle theorem. I'll repeat again. Angle BAC equals to angle FEC according to third angle theorem. So what is third angle theorem? Third angle theorem is that if you prove the two angles in one triangle congruent to two angles in another triangle, then the first pair of angles must also congruent because they are complementary to 180 degrees. And we proved that those two angles in the right triangle ABC congruent correspondingly to those two angles in the right triangle EFC. Therefore, the first pair of angles must be also congruent because of the fact that they are complementary to 180 degrees. Okay? So we actually proved that all the angles of triangle ABC congruent to all the angles in triangle EFC. Therefore, we proved that triangle ABC is similar, this is the sign of similar, to triangle EFC. EFC according to angle similarity rule. Okay, and from the fact that triangle ABC is similar to triangle EFC, we conclude that AB over BC is equal to EF over FC. Again, AB over BC in triangle ABC is equal to EF over FC in triangle EFC. Okay, according to equation number 1, because of the fact that triangle ABC is similar to triangle EFC, we will conclude that AB over BC equals to EF over FC. AB equals to 6 units, BC equals to Y plus 10, and it is equal to EF, that is Y, over FC, that is 4. So in conclusion, we found out that according to equation number 1, 6 over Y plus 10 equals to Y over 4. Here we will cross multiply equation number 1, and we'll get that according to equation number 1, 6 times 4 is 24, and it is equal to Y times Y plus 10. Here we will open the brackets on this side of equation number 1, and we will get that according to equation number 1, (24) equals to Y times Y is Y squared, plus Y times 10 is 10Y. So we found out that according to equation number 1, 24 equals to Y squared plus 10Y. Here we subtract 24 from this equation, and we will get that according to equation number 1, Y squared plus 10Y minus 24 is equal to 0. So this is a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to the following formula. X is actually equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Okay, in our specific quadratic equation, the coefficient a is equal to 1, the coefficient b is equal to 10, and the coefficient c equals to minus 24, and the variable that we are looking for is y, so x equals to y. We'll put the data inside the formula for x, and we find out the value of the values of y. So we get that y equals to minus b, b is 10, so minus b is minus 10, plus minus square root of b squared, b is 10, so b squared is 10 squared, that is 100, minus 4 times a is 1, times c, that is minus 24, over 2a. A is 1, so 2 times 1 is 2. So here we found out that y is equal to minus 10 plus minus square root of minus 4 times minus 24 is 96, and 96 plus 100 is 196. So inside the root we have 196 over 2. The square root of 196 is 14. So we get that y equals to minus 10 plus minus 14 over 2. So here we have two solutions that are possible for y. The first solution, y1 is equals to minus 10 minus 14 is minus 24. Minus 24 over 2 is minus 12. And the second solution for y is y2 equals to minus 10 plus 14 over 2. 14 minus 10 is 4, and 4 over 2 is 2. So y2 equals to 2. We'll focus on the first solution. y1 equals to minus 12. Okay, so here y1 cannot be equal to minus 12 because of the fact that y is a length. Y is the length of side B of the right triangle, triangle ABD, and as a length it cannot be a negative number. So y is a length, therefore it must be a positive number. Therefore, the solution that y1 equals to minus 12 is incorrect because y must be equal to a positive number. So we cancel the solution. We left only with the solution that y2 equals to 2. So I copy the right triangle, triangle ABD in the new page, and we will implement the Pythagoras theorem on the right plane triangle, triangle ABD. Okay? So in the right triangle, triangle ABD, the square of the hypotenuse equals to the sum of the squares of the perpendiculars according to the Pythagoras theorem. PT is Pythagoras theorem. So we get that the square of the hypotenuse is AD squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AB squared plus BD squared. AD equals to x, so AD squared is x squared. That is equal to AB squared. AB is 6, so AB squared is 6 squared, that is 36, plus BD squared. BD is 2, so BD squared is 2 squared, that is 4. So we found out that x squared equals to 36 plus 4 is 40. We take a root out of this equation, and we'll get that x equals to the square root of 40. 40 is 4 times 10. So in conclusion, we found out that x, the line segment that we are looking for, it is equal to either 2 times the square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, so we finished with the second method. In the next step, I will present to you how to find out the value of line segment x according to the first method. In the third method, here it is actually A, B, C, A, B, D, and C. So here we define angle BAD as theta and side BD as Y. And here, if you focus on the right triangle, triangle ABD, we'll get that tangent theta equals to BD over AB. BD equals to Y according to our definition, AB equals to 6 according to what is given us in the question. So in conclusion, we found out that in the right triangle, triangle ABD, tangent theta equals to Y over 6. Okay? In the next step, we will focus on the right triangle, triangle ABC. In the right triangle, triangle ABC, tangents theta plus 45 degrees. This will be equation number 1. Tangents theta plus 45 degrees equals to BC over AB. BC over AB. BC equals to Y plus 10. And AB equals to 6 according to what is given us in the question. So in conclusion, we found out that according to equation number 1, tangents theta plus 45 degrees equals to Y plus 10 over 6. Okay? We actually have trigonometric identity for tangents theta plus 45 degrees. The trigonometric identity for tangent theta plus 45 degrees is actually equals to 1 plus tangent theta over 1 minus tangent theta now we can substitute tangent theta plus 45 degrees in this equation, equation number 1, by this expression. So we'll do it now, and we get it according to equation number 1, tangent theta plus 45 degrees, that is equal to 1, according to this trigonometric identity, it is equal to 1 plus tangent theta over 1 minus tangent theta, and it is equal, according to equation number 1, to Y plus 10 over 6. We have already found out that tangent theta equals to Y over 6, so we substitute tangent theta in this equation, equation number 1, by Y over 6. And we get that according to equation number 1, 1 plus tangent theta is Y over 6, over 1 minus tangent theta is Y over 6. It is equal to Y plus 10 over 6. Here we multiply 1 by 6 and then we divide it by 6 in order to have a common factor with Y plus 6 and Y minus 6, with Y over 6 and Y and minus Y over 6. So 6 plus Y over 6 equals to 6 minus y over 6, and it is equal to y plus 10 over 6. Okay, this is equation number 1. Here we have 6 in the numerator and 6 in the denominator, so 6 will get cancelled, and we left only with 6 plus y over 6 minus y, that is equal to y plus 10 over 6. Here we will cross multiply this equation, equation number 1, and we will get that according to equation number 1, 6 times 6 plus y equals to 6 minus y times y plus 10. Here we will open the brackets on both sides of equation number 1, and we will get that according to equation number 1, 6 times 6 is 36, plus 6 times y is 6y, and it is equal to 6y, plus 6 times 10 is 60, minus y times y is minus y squared, minus y times 10 is minus 10y. Here we have 6y on both sides of the equation, so 6y will get cancelled. So what is left from equation number 1 after we cancelled 6y? What is left? It is actually in this side we have 36. In the other side we have 60 minus y squared minus 10y. Here we will add y squared and 10y to this equation, equation number 1. And we will get that according to equation number 1, y squared plus 10y plus 36 equals to 60. We will subtract 60 from this equation, equation number 1, and we will get that y squared plus 10y, 36 minus 60 is minus 24, equals to 0. Here we have the same quadratic equation as we had in the second method. The solution to this quadratic equation, it has two solutions. The first solution is y1 equals to minus 12, and the second solution y2 equals to 2. But because of the fact that y is the length of side BD, y is a length, it cannot be a negative number, it must be a positive number, so the solution that y equals to minus 12 is incorrect solution. We will cancel this solution, and we left only with the solution that y equals to 2 units. So copy the right triangle, triangle ABD in a new page, and we will implement the Pythagoras theorem on the right triangle, triangle ABD. Okay? So in the right triangle, triangle ABD, AB equals to 6, AD equals to x, BD, we already found out that is equal to 2. So according to the Pythagoras theorem, if we implement it on this right triangle, triangle ABD, with PT, Pythagoras theorem, we'll get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AD squared equals to AB squared plus BD squared. AD equals to x, so AD squared is x squared. AB equals to 6, so AB squared is 6 squared, that is 36. BD equals to 2, so BD squared is 2 squared, that is 4. 36 plus 4 is 40, so we found out that x squared equals to 40. We take a root out of this equation, and we get that x equals to the square root of 40. 40 is 4 times 10. The square root of 4 times 10 is equal to 2 times square root of 10 units, so in terms of numbers it is equal to 6.32 units. Okay, we found out that x equals to either 6.32 units, or we can also present it as 2 times square root of 10 units. In the next step, I'll summarize the lecture. Actually, we wanted to find out the value of line segment x in the first method. We have a triangle ABC. It is a right triangle. AB equals to 6 units, DC equals to 10 units, angle DAC equals to 45 degrees, angle ABC equals to 90 degrees, and we want to find out the length of line segment AD that is actually equals to X. So here we did the construction, we extended line segment AD by a straight line, and from point C we drew perpendicular on the extended AD. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction, and we define the touching point of the perpendicular from point C and AC as E. So in triangle AEC, we know that the sum of the angles must be equal to 180 degrees. So which angles we have here? In the right triangle, triangle AC, we have 45 degrees, we have 90 degrees according to our construction, and we have the missing angle, angle ACE. In total, the sum of those three angles must be equal to 180 degrees. We subtracted 135 degrees from this equation, and we got that the missing angle, angle ACE, this angle equals to 180 degrees minus 135 degrees, it is 45 degrees. So in triangle ACE, it is right triangle, and it is also isosceles triangle. We have two angles that are equal to each other, and according to the rule that in front of equal angles in the triangle there are equal sides, we get that side AE must be equal to side EC. AE must be equal to side EC. We define DE as Y, therefore AE equals to X plus Y. So here, from this equation, X plus Y equals to AE equals to EC, we will derive that EC is also equals to X plus Y. So we can write here that EC equals to X plus Y. Then those two angles, they are equal to each other, they are vertex angles. Vertex angles are equal to each other. So if we define one angle as Y, then the other angle must be also equal to Y. Because they are equal to each other, and if this angle is alpha, so if we define one angle as alpha, then the other angle must be also equal to alpha, because of the fact that vertex angles are equal to each other. So both those two angles will be equal to alpha. So if this angle equals to alpha in the right triangle ABD, this angle must be equal to 90 degrees minus alpha, because of the fact that in total the sum of all those angles must be equal to 180 degrees, and 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees it is 180 degrees. So this angle equals to 90 degrees minus alpha. Likewise, for the same reason, in the right triangle DEC, this angle must be also equal to 90 degrees minus alpha in order to complete the sum of the angles in this triangle, to 180 degrees. Okay, so here we actually proved that those two right green triangles are similar to each other. Those right green triangles are similar to each other. First of all, those two angles are equal to each other, they are both equal to alpha. Those two angles are also equal to each other, they are both equal to 90 degrees minus alpha, and those two angles are also equal to each other, they are both equal to 90 degrees. So all the angles of triangle ABD can combine to all the angles of triangle DEC. Therefore, we can write down that the right green triangle, triangle ABD is congruent to the right triangle, triangle EDC according to angle similarity rule. From the fact that those two right triangles congruent to each other, we will conclude that the following relationship exists between their sides. That is to say, we will conclude that AB over EC equals to BD over DE equals to AD over DC. Okay? AB over EC equals to BD over DE equals to AD over DC. AB equals to 6, EC equals to X plus Y, BD is BD, DE equals to Y, according to our definition, AD equals to X according to what is given us the question, and DC equals to 10 units according to what is given us the question. So in conclusion, we found out that 6 over X plus Y equals to BD over Y, that is equal to X over 10. In order to find out the length of line segment BD or side BD, we implemented the Pythagoras theorem on the right green triangle, triangle ABD. according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the slopes of the perpendiculars. That is to say, AD square equals to AB square plus BD square. Here, AD square equals to AB square plus BD square. AD equals to x, so AD square is x squared. AB equals to 6, so AB square is 6 squared, this is 36, plus BD square is the missing line segment. Here we subtracted 36 from this equation, and we got that BD square equals to x squared minus 36. We took the root out of this equation and found out that BD equals to the square root of x squared minus 36. So we can substitute BD in equation number 1 here by square root of x squared minus 36. We did it, and we got that according to equation number 1, here 6 over x plus y equals to BD, that is x squared minus 36, over y, that is equal to x over 10. Here we created two equations from this long equation. The first equation is that those two expressions are equal to each other. That is to say, 6 over x plus y equals to x over 10. We cross-multiplied this equation and found out that 6 times 10 is 60, and 60 equals to x times x, y times x plus y. We opened the brackets in this side of the equation number 1 and found out that 60 equals to x times x, that is x squared, plus xy. Then we subtracted x squared from this equation and found out that according to equation number 1, xy equals to 60 minus x squared. Then we created equation number 2 from this long equation. Those two expressions are equal to each other. That is to say, square root of x squared over square root of x squared minus 36 over y equals to x over 10. We cross multiply this equation number 2, and we got that xy equals to 10 times square root of x squared minus 36. We squared both those two sides, both sides of equation number 2, and we got that actually x squared according to equation number 2 equals to xy according to equation number 2 equals to 10 times square root of x minus y squared. Then we created equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. Xy according to equation number 1 is 60 minus x squared, and it must be equal to xy according to equation number 2. That is actually 10 times square root of x squared minus 36. We squared both sides of equation number 3, and we got that 60 minus x squared equals to 10 squared, that is 100. Here the square cancels the root, and we left only with x squared minus 36. We open the brackets on both sides of equation number 3, and we got that 60 minus x squared equals to 60 minus x squared equals to 60 squared, that is 3600, plus x squared, that is x to the power of 4, minus 2 times 60 times x squared, and it is equal to 100 times x squared, minus 3600. Here we added 3600 to this equation number 3, and we got that 3600 plus 3600 is 7200, plus x to the power of 4, minus 2 times 60 is 120x squared, that is equal to 100x squared. Here we subtracted 100x squared from this equation, and we got that minus 120x squared minus 100x squared is minus 220x squared, and we have also x squared plus 7200. So in conclusion, we found out that according to equation number 3, x squared equals to minus 220x squared plus 7200. Then we substituted minus 220x squared by minus 180x squared minus 40x squared. And we divided equation number 3 to two parts, and we took a common factor from each part. From this part, we took x squared as a common factor, so inside the brackets we will have x squared minus 180. From this part, we took minus 40 as a common factor, so inside the brackets what we will have is x squared minus 180. Here, from here we took x squared minus 180 as a common factor, and inside the brackets what we will have is x squared minus 140. So here we will have two solutions that are possible for x. The first solution for x is x squared minus 180 equals to 0. And the second solution is x squared minus 40 equals to 0. So according to the first solution, x squared equals to 180. 180 is 36 times 5. we took out of this equation number 1, and we found out that x squared, that x equals to the square root of 36 times 5. The square root of 36 is 6. So in conclusion, we found out that x equals to 6 times square root of 5 units, or in terms of numbers, it is 13.41 units. That is greater than 10. And according to the second equation, x squared equals to 40. 40 is 4 times 10. We took out of this equation number 2, and we got that x equals to the square root of 4, that is 2. So in conclusion, x equals to 2 times square root of 10 units. Or in terms of numbers, it is 6.32 units, that is less than 10 units. Okay? In the next step, I copied triangle ABD and triangle ADC in a new page, and we analyzed those two triangles in order to find out which one of the two solutions is correct in relation to the drawing. This is triangle ABD, the right triangle. AD equals to x. This angle equals to theta. This angle equals to alpha. So inside triangle ABD, we have three interior angles, that is theta, alpha, and 90 degrees. And outside of triangle ABD, we have angle ADC, that is defined as an exterior angle to triangle ABD. So angle ADC is an exterior angle of triangle ABD. Okay? And we have rule number 1 that relates to the size of an exterior angle. According to rule number 1, the size of an exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So according to rule number 1, the size of this exterior angle ADC equals to the sum of the two interior angles that are not adjacent to it. This angle alpha is adjacent to it. Angle alpha is adjacent to angle ADC, therefore the two other angles that are not adjacent to it are theta and 90 degrees. And the sum of those two interior angles that are not adjacent to angle ADC is 90 degrees plus theta. So in conclusion, we found out that according to rule number 1, angle ADC equals to 90 degrees plus theta. And we also know that the sum of the angles in triangle ADC must be equal to 180 degrees. So which angles we have in triangle ADC? We have one angle that is 45 degrees. This angle ADC equals to 90 degrees plus theta. And the missing angle ACD. In total, the sum of those three angles must be equal to 180 degrees. We subtracted 135 degrees from this equation, and we found out that angle ACD plus theta equals to 45 degrees, because 180 degrees minus 135 degrees is 45 degrees. We subtracted theta from this equation, and we found out that angle ACD equals to 45 degrees minus theta. So this angle ACD equals to 45 degrees minus theta, so it is very easy to see from the drawing that this angle ACD that is equal to 45 degrees minus theta is the smallest angle in triangle ADC. Okay, we can write here that angle ACD that is equal to 45 degrees minus theta is the smallest angle in triangle ADC. And we have also rule number 2, that the smallest angle in a triangle is always opposite to the shortest side. So according to rule number 2, this is the smallest angle, and it is located opposite the smallest side. The opposite AD is opposite to this angle. AD that is equal to x is opposite to this angle. So we can write down that AD that is equal to x is the shortest angle in triangle ADC. And because of the fact that AD that is equal to x is the shortest angle, it is less than the length of DC, that is 10 units. So we can write down that AD that is equal to x is less than side DC of triangle ADC, that is 10 units. That is to say, from this equation, we can derive that AD is less than 10 units, so x is also less than 10 units. So we know that x must be less than 10 units. But according to the first solution, x that is equal to 6 times square root of 5, that is 13.41, is greater than 10 units. So this solution is incorrect solution because x must be less than 10 units, and here x is greater than 10 units. So this solution is incorrect solution, and we left only with the solution that x equals to 2 times square root of 10 units, that is 6.32 units, that is less than 10 units. So the solution to the question that x is equal to 2 times square root of 2 units, or you can present it also as 6.32 units. We finish with the first method. In the next step, I presented to you how to find out the length of side AD according to the second method. In the second method, we did another construction. From point D, we drew a straight line on AC in such a way that angle AED will be equal to 45 degrees. So angle AED equals to 45 degrees according to our construction. So in triangle ADE, we have two angles that are equal to each other. And according to the rule that in front of equal angles in the triangle there are equal sides, we will get that AD must be equal to DE. AD equals to DE, but we know that AD equals to X according to what is given us in the question. So from this equation X equals to AD equals to DE, we will derive that DE is also equals to X. So here DE equals to X. And we know that the sum of the angles in triangle ADE must be equal to 180 degrees. So each angles we have in triangle ADE, we have 45 degrees. And this angle is also equal to 45 degrees. And we have angle ADE. In total, the sum of those three angles must be equal to 180 degrees. 45 degrees plus 45 degrees is 90 degrees. We will subtract 90 degrees from this equation, and we will get that the missing angle ADE equals to 180 degrees minus 90 degrees. It is 90 degrees. So we found out that angle ADE is a right angle, therefore triangle ADE is a right triangle. Then we defined angle BAD as theta. And because of the fact that the green triangle is a right triangle, this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles to 180 degrees. So angle ADB equals to 90 degrees minus theta, angle ADE equals to 90 degrees, and we have also here angle EDF, that is the missing angle. Actually, we know that triangle ABC is a right triangle. Therefore, BC is one side of a right triangle, and as a side of a triangle, BC must be a straight line. Okay, BC is a straight line because it is one side of a right triangle. So we have the rule that says that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BC at point D, then the sum of the angles on the upper side of BC at point D must be equal to 180 degrees. So which angles we have on the upper side of BC at point D? We have 90 degrees minus theta, we have 90 degrees, and we have the missing angle EDC. In total, the sum of those three angles must be equal to 180 degrees. 90 degrees plus 90 degrees is 180 degrees, so we have 180 degrees on both sides of the equation, so 180 degrees will get cancelled, and we left only with minus theta plus angle EDC, that is equal to 0. We added theta to this equation, and we found out that the missing angle EDC equals to theta. Here, this angle equals to theta, therefore, this angle EDF equals to theta. Then we made another construction. From point E, we drew perpendicular on BC, and we defined the touching point as F. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. So in the right triangle, triangle DEF, this angle equals to theta, so this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in the right triangle DEF to 180 degrees. Then we proved that those two right green triangles can go into each other. So why those two right triangles can go into each other? First of all, those two angles are equal to each other, they are both equal to theta. Those two angles are also equal to each other, they are both equal to 90 degrees minus theta. And side AD equals to side DE, and they are both equal to X. So we found how those two triangles can go to each other according to angle side angle rule. We have two angles and the side which is between them in this triangle ABD congruent correspondingly to those two angles and the side that is located between them in the right triangle EDF. Therefore, those two triangles can go into each other according to angle side angle rule. And from the fact that those two triangles can go into each other, we will conclude that AB equals to DF. AB equals to DF according to the rule that corresponding sides and congruent triangles are equal to each other. So, but we know that AB equals to 6. AB equals to DF, but AB equals to 6. So from this equation, 6 equals to AB equals to DF, we will derive that DF is also equals to 6. Here DF equals to 6. And because of the fact that DF equals to 6, then FC will be equal to DC minus DF. Okay, here FC equals to DC minus DF. So FC equals to DC, that is 10 units, minus DF, that is 6. 10 minus 6 is 4. So we found out that FC equals to 4 units. Likewise, BD must be equal to EF because of the fact that those two right green triangles can go into each other. They are equal to each other according to the rule that corresponding sides in congruent triangles are equal to each other. So BD equals to EF. If we define BD as Y, then from this equation Y equals to BD equals to EF, we derive that EF is also equals to Y. So if EF equals to Y, then we proved that the right triangle ABC, is congruent, is similar to the right triangle EFC. Why those two right triangles are similar to each other? First of all, those two angles, they are equal to each other, they are both equal to 90 degrees. This angle is a common angle, it belongs to both triangles. And those two angles, they must also equal to each other according to third angle theorem. What is third angle theorem? Actually, if we prove that two angles in one triangle congruent to two angles in another triangle, then the first pair of angles must also congruent. And we proved that those two angles in triangle ABC congruent correspondingly to those two angles in triangle EFC. Therefore, the third pair of angles, those two angles must also congruent because they are complementary to 180 degrees. So we found out that all the angles of triangle ABC congruent to all the angles in triangle EFC. Therefore, those two triangles therefore those two triangles are similar to each other according to angle similarity rule. Okay, and because of the fact that triangle ABC is similar to triangle EFC, we will conclude that the following relationship exists between their sides. We will conclude that AB over BC equals to EF over FC. Okay, here AB over BC equals to EF over FC. AB equals to 6, BC equals to Y plus 10, EF equals to Y, and FC equals to 4. So in conclusion, we found out that according to equation number 1, 6 over Y plus 10 equals to Y over 4. Because multiply the equation number 1, and we found out that 4 times 6 is 24 equals to Y times Y plus 10. We open the brackets on this side of equation number 1, and we found out that according to equation number 1, (24) equals to Y squared plus 10y. We subtracted 24 from this equation number 1, and we found out that y squared plus 10y minus 24 equals to 0. This is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. here A, B, and C are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following formula. X is equal to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a is equals to 1, the coefficient b equals to 10, and the coefficient c equals to minus 24. And the variable that we are looking for is y, so x equals to y. So here we'll put the data inside this equation and for x, and we find out the values of y, because y equals to x. So y equals to minus b equals to 10, so minus b is minus 10, and it is equal to the square root of b squared. B is 10, so b squared is 10 squared, that is 100, minus 4 times a is 1, c is minus 24. Over 2a, 2 times a is 1, 2 times 1 is 2. Minus 4 times minus 24 is plus 96. 96 plus 100 is 196. And the square root of 196 is 14. So we got that y equals to minus 10 plus minus 14 over 2. So here we have two solutions that are possible for y. The first solution, y1 equals to minus 10 minus 14, that is minus 24 over 2. So the first solution, y1, is minus 24 over 2, that is minus 12. And the second solution is minus 10 plus 14, that is 4. 4 over 2 is 2. So the second solution is that y equals to 2. But the second solution is incorrect solution because of the fact that y is a length. And because of the fact that y is a length, it must be a positive number. So y cannot be a negative number. Therefore, y equals to minus 12 is the incorrect solution. We cancel the solution, and we left only with the solution that y2 equals to 2. Then I copied triangle ABD in this new page, and we implemented the Pythagoras theorem on this right triangle, triangle ABD. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AD squared equals to AB squared plus BD squared. AD is x, so AD squared is x squared, and it is equal to AB squared, AB 6, so AB squared is 6 squared, that is 36, plus BD squared. BD is 2, so BD squared is 2 squared, that is 4. 36 plus 4 is 40. So we found out that x squared equals to 40. We took out of this equation and found out that x equals to 2 times square root of 10 units, so we can present it also as 6.32 units. Okay, so we finished here. If the second method, then I presented to you how to find out the value of line segment x according to the third method. In the third method, we defined angle BAD as theta and side BD as y. So in the right triangle ABD, we know that tangent theta is equal to BD over AB. BD is y, AB is 6. So in conclusion, we found out that in the right triangle ABD, tangent theta equals to y over 6. Then we focus on the right triangle ABC. In the right triangle ABC, tangent theta plus 45 degrees equals to BC over AB. Tangent theta plus 45 degrees equals to BC over AB. BC equals to y plus 10. AB equals to 6. So in conclusion, found out that according to equation number 1, tangent theta plus 45 degrees equals to y plus 10 over 6. Actually, we have trigonometric identity for tangent theta plus 45 degrees. Tangent theta plus 45 degrees equals to 1 plus tangent theta over 1 minus tangent theta. Therefore, we can substitute tangent theta plus 45 degrees in equation number 1 by this expression. We did it, and we got that according to equation number 1, 1 plus tangent theta over 1 minus tangent theta equals to y plus 10 over 6. We have already found out that tangent theta equals to y over 6, so we can substitute tangent theta by 1 over 6 in equation number 1. We did it, and we got that 1 plus tangent theta, that is y over 6, over 1 minus tangent theta, that is also y over 6, equals to y plus 10 over 6. Here we multiplied 1 by 6 and then we divide it by 6 in order to have a common factor with y over 6 and with minus y over 6. So we got that 6 plus y over 6 over 6 minus y over 6 equals to y plus 10 over 6. We have 6 in the numerator and 6 in the denominator, so 6 will get cancelled and we left only with 6 plus y over 6 minus y equals to y plus 10 over 6. Because we multiplied this equation number 1, and we got that 6 times 6 plus y equals to 6 minus y times y plus 10. 6 times 6 is 36, 6 times y is 6y, 6 times y is 6y, 6 times 10 is 60, minus y times minus y is minus y squared, minus y times 10 is minus 10y. We have 6y on both sides of the equation, so 6y will get cancelled, and we left only with 36, that is equal to 60 minus y squared minus 10y. We added y squared and 10y to this equation number 1, and we got that according to equation number 1, y squared plus 10y plus 36 equals to 60. We subtracted 60 from this equation number 1, and we got that according to equation number 1, y squared plus 10y minus 24 equals to 0. So here, this quadratic equation, we solved it already in a second method, and we found out that this quadratic equation has two solutions. The first solution is y1 equals to minus 12, and the second solution y2 equals to 2. The first solution is incorrect solution because y must be a negative number because it is a length. A length must be positive. Y is a length, and as a length, it must be a positive number. Therefore, y equals to minus 12, that is a negative number, is incorrect solution. We cancel this solution, and we left only with the solution that y2 equals to 2. Then I drew the right triangle ABD, and we implemented the Pythagoras theorem on the right triangle ABD. The square of the hypotenuse equals to the sum of the surfaces of the perpendiculars, according to the Pythagoras theorem. That is to say, AD square equals to AB square plus BD square. AD equals to x, so AD square is x square, and it is equal to AB square. AB is 6, so AB square is 6 squared, that is 36, plus BD square. BD is 2, so BD square is 2 squared, that is 4. 36 plus 4 is 40, so in conclusion we found out that x squared equals to 40. 40 is 4 times 10, so x, we took out of this equation and found out that x equals to the square root of 4 times 10, that is to say x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, thank you very much.